Hey everyone, welcome back. Today we are going to solve problem number 1514, path with maximum probability. First, we'll see the explanation of the problem statement, then the logic and the code. Now let's dive into the solution. So in this problem, we are given an undirected weighted graph of n nodes. So here n is 3. So we have 3 nodes here, 0, 1 and 2. And we have given an edges list. So the edges list represents the connection between two nodes. So here we have 0, 1 connection and 1, 2 are connected and 0, 2 is also connected here, right? Then we are given the weights for each and every connection. So for 0, 1 path, we are given a probability of 0.5. Similarly, for 1, 2 path, we are given 0.5 and for 0, 2, we are given 0.2. And then we are given two variables, start and end. So the goal of the problem is to find the maximum probability that I can find between the two nodes 0 and 2. So first we need to start from 0, right? Since the start is 0, we need to start from 0. And then we need to check how I can reach 2. So here we have the direct connection between 0 and 2, right? So the probability is 0.2. Also I can reach 2 from 0 by traveling from 0 to 1 and 1 to 2, right? This is also a possible path. So when you have multiple paths, we need to multiply those probabilities. So here probability between 0 and 1 is 0.5 and the probability between 1 and 2 is 0.5. So here we are going to get 0.25. So we can reach the node 2 from 0 with two possible ways. So we need to pick the possible way which gave me the maximum probability here. So here 0.25 is the maximum probability, right? So this path from 0 to 1 and 1 to 2 is the maximum probability path. So we need to return 0.25 as my answer for this particular input, right? So to solve this problem, we are going to use breadth first search approach. So now we will see how we are going to do this. So here we are representing the graph in a dictionary. So here the connection between 0 and 1 has been stored and that connection index will be stored with 1. So the connection index between 0 and 1 is 0th index, right? So we are storing 0 here. Then there is a connection between 0 and 2 and their index is 2, right? And since this is an undirected graph, we need to do it for the other nodes as well. So here we have represented the connection between 1 and 0 and their connection index is 0 and so on, right? So then we are going to create a list of zeros and we are going to create this list of zeros based on the number of nodes. So here we have 3 nodes, so we have 3 zeros here, right? So the intuition behind this approach is that we are going to calculate the maximum probability for each and every node, right? By doing this, we can easily access the maximum probability for the given end node, right? So then we are going to make the starting node's probability as 1 at the start. So the starting node is 0. So we are going to make the 0th node probability as 1. We are initializing it as 1, right? Then we will be having a queue. In the queue, we will be appending the starting node at the start. So here we have 0. Now we need to pop the first entered element in my queue. So here we have only 0. So we pop 0. So current node will be 0, right? Now we are going to analyze the neighbors of 0. So first we pick the first neighbor in my dictionary. So the first neighbor of 0 is 1. The neighbor is 1 and their connection index is 0. I will make this as I. So now using this index value 0, we have to pick the connections probability score. So the probability score between 0 and 1 is 0.5, right? 0 and 1 is 0.5. So we pick that probability score and now we need to multiply this with the current node's probability score. So the current node's probability score is 1. Current node is 0. So the 0th node probability score is 1. So this will be 0.5. Now we need to compare this probability score with the neighbor's probability score. So the neighbor's probability score is 0. Since 0.5 is greater than 0, we need to assign this 0.5 to the neighbor's probability score. So the neighbor is 1. So at the first index, I will make this as 0.5. So this is the maximum probability for node 1 so far. After updating the neighbor, we need to append 1 to the queue. Then we pick the next neighbor of 0, that is 2, and their index is 2. So the index value of the connection of 0 and 2 is 2, right? So now we need to take the probability score of this connection, that is 0.2, and we need to multiply with the current node's probability score, which is 1. It is going to be 0.2 only. Then we need to compare this score with the neighbor's probability score, which is 0. Neighbor is 2, and in the second index there is 0. So here 0.2 is greater than 0. So we need to update the neighbor's probability score with 0.2, right? So in the second index, it becomes 0.2. After updating, we need to append 2 to the queue. So now we are done with all the neighbors of 0. Then we need to pick the next node from the queue, that is 1, right? So the first neighbor of 1 is 0, right? So the neighbor is 0 and their index is 0. So now we need to take the probability score of the connection, that is 0.5, and we need to multiply with the current node's probability score, that is 1. So we need to take the probability score of 1, which is 0.5. Here we are going to get 0.25, and then we need to compare this with the neighbor's probability score, which is nothing but 1. So here 0.25 is not greater than 1. So we don't have to append 0 in the queue, as well as we don't have to update 0 in the probability scores, right? Then we pick the next neighbor of 1, that is 2, and their connections index is 1. So we need to take the probability score for the current connection, that is 0.5. First index connections probability score is 0.5, right? Then we need to take the probability score of the current node, that is 0.5, right? We need to multiply with that one. Then we are going to get 0.25, right? Then we need to compare this with the neighbor's probability score, that is 0.2. So neighbor is 2, so the second index probability score is 0.2. So since 0.25 is greater than 0.2, we need to update this value in the neighbor's probability score, right? So here in the neighbor's probability score, it becomes 0.25. Then we need to append 2 again in the queue. So we just have to keep on doing this until my queue is empty. Here the probability scores is not going to change. So we need to return the probability score that exists in my end node 2. So here the answer will be 0.25. That's all the logic is. Now we will see the code. So before we code, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future, and also check out my previous videos and keep supporting guys. So initially we are initializing the graph as my list dictionary, and I will be appending the starting node in my queue. Then I will be writing a for loop where I will be representing the connections in the dictionary, right, with their connection indices. Then we are creating the list of zeros for the length of n, where we will store the probability scores, and we are initializing the starting node's probability score as 1 at the start, right? Then we will be writing a while loop. We will run the while loop until the queue is empty. So initially we will pop the first entered element in the queue, that will be the current node. Then we will analyze all the neighbors of the current node using the graph dictionary, right? Then we will multiply the current node's probability score and the current connections probability score. Then we will compare that value with the neighbor's probability score. If the calculated value is greater, we need to update our neighbor's probability score, right? After that, I will append the neighbor to the queue. Then finally, we need to return the maximum probability score of the end node in the probability list, right? That's all the code is. Now we will run the code. So the time complexity will be order of n into e. So where n is the number of nodes and e is the number of edges, right? And space complexity will be n plus e. Thank you guys for watching this video. Please like, share and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos. Keep supporting. Happy learning. Cheers guys.